Hi, this is Uday Chandran. I have done BE in Aeronautical Engineering. Now we are going to see about aerodynamics. Before that, let me see what are the basic concepts behind an airplane. First of all, let me see what are the forces acting on the airplane. In general, an aircraft flying under the influence of four forces which are lift, drag, thrust, weight. In order for the aircraft flying under the steady state condition, there must be a balanced condition between these four forces. That is lift equal weight and thrust equal drag. Here lift and thrust are positive impact, drag and weight are negative impact. And what is lift? Lift is the force that trying to lift the airplane from the sea level. Here let me see how the lift force is provided. This is airfoil. Airfoil is nothing but the cross section of the wing. Here the air moving over the top of the wing is caused to go faster than the slower moving air on the bottom side of the wing. Generally faster moving air has less pressure. So therefore, here top of the wing has less pressure and bottom side of the wing has more pressure. So the plane automatically lifted. This is called Bernoulli's principle. What is Bernoulli's principle? An ideal incompressible fluid, when the flow is steady and continuous, the sum of the pressure energy, kinematic energy and potential energy constant along the streamline. Next one is drag. Drag is the force that trying to pull the airplane backward direction. The total drag produced by the airplane is sum of the profile drag, induced drag, parachute drag. What is profile drag? Profile drag is the drag incurred from the frictional resistance of the bed passing through the air. And next one is induced drag. Induced drag is the drag formed as a result of lifting portion of the aircraft. And next one is parachute drag. Parachute drag is the drag incurred from the non-lifting portion of the aircraft. And next one is thrust. Thrust is a force that trying to pull the airplane forward direction. Here the thrust force is produced by the propeller of the jet engine. And next one is weight. Weight is the force that trying to pull the airplane back to the earth. Here the total weight acts at the one point, that is center of gravity. Center of gravity is nothing but the average location of the average weight of the aircraft. And next one is lift diagram. This is airfoil. Airfoil is nothing but the cross section of the wing. And this is leading edge and this is trailing edge. Leading edge is nothing but the most forward edge of the wing, and trailing edge is nothing but the most rear edge of the wing. And this is direction of the flight. Here alpha denoted as angle of attack. Angle of attack is nothing but the angle between the chord line and the relative direction of the aircraft. And this is chord line. Chord line is the line between the leading edge and the trailing edge. Generally, if the produced rate is greater than the weight of the aircraft so the aircraft can lift it. And next one is control surface. Control surface is used to control the aircraft movement in different directions. One is elevator, next one is rudder, and next one is aileron. Elevator is used to control the nose of the airplane up and down direction, that is pitching motion. It has to be fixed in fin of the aircraft. And next one is rudder. Rudder is used to control the nose of the airplane from left to right and right to left. It has to be fixed in the tail of the airplane. And next one is aileron. Aileron is used to control the rolling motion of the aircraft. It has to be fixed at wing. And next one, this is the diagram shows axis in aircraft. This is yawing movement, and this is pitching movement, and this is rolling movement of the aircraft. And next one is major components of the aircraft. One is wing, fuselage, empennage, control surface, landing gear, and power plant. First one is wing. Wing is used to produce the lift. And next one is fuselage. Fuselage is nothing but the whole body of the aircraft. It has to carry payloads and passengers of the aircraft. Next one is empennage. Empennage is nothing but the tail and fin portion of the aircraft. This is the empennage of the aircraft. And next one is control surface. Control surface is nothing but control the aircraft movement in different directions. Elevator, rudder, and aileron are the different types of control surface. And next one is landing gear. Landing gear is nothing but used to support the aircraft in land. And next one is power plant. Power plant is nothing but the engine of the aircraft. It is used to produce thrust. And this is the total drag produced by the aircraft with respect to the forward speed. Here total drag is sum of the profile drag, parachute drag, and induced drag. Here dotted line E shows the forward speed of the forward airspeed range of the aircraft. Next one is loads acting on the airplane. One is gust load. Gust load is nothing but the vertical air. And next one is thermal load. Thermal load is formed due to the formation of any electrical circuits and engine heat, like etc. Next one is landing load. Landing load is formed during landing condition, landing and landing gear of the aircraft. And next one is power plant. Power plant load is nothing but the engine of the aircraft. It has formed due to engine of the aircraft. And next one is major aircraft systems. One is brake system, navigation system and communication system, fuel and engine system, instrumentation system, air conditioning system. First one is brake system. What is brake system? It is used to control the aircraft speed. And next one is navigation system. Navigation system is used to increase the navigation system is used to include the pitching and controlling the aircraft movement in different directions from one place to another and controlling the aircraft movement from one place to another. And next one is communication. Communication is nothing but the communication process. It is communication between land to airplane and plane to airplane. Next one is fuel and engine system. Fuel and engine system is nothing but the fuel system of the aircraft and engine system of the aircraft. It includes engines and fuel tanks, some of the components, etc. And next one is instrumentation. Instrumentation includes the fire protection system, rainwater removal system, and oxygen management system. The next one is air conditioning system. Air conditioning system includes the air conditioning system includes the air cooler of the aircraft. Next one is aircraft manuals. Aircraft in airplane done the takeoff, climb, landing, turn and bank, descent, cruise. It has to be done the different types of manuals, and fighter aircraft done additional manuals like looping, rolling, etc. And next one is aircraft instruments. What are the aircraft instruments used in airplane? One is magnetic compass. Magnetic compass is used to find the heading of the airplane when it is during flying condition. Next one is airspeed indicator. Airspeed indicator is used to tell the airspeed of the aircraft through air. Next one is altitude indicator. Altitude indicator tells the nose of the airplane whether the nose of the airplane is above or below with respect to the horizontal. Next one is altimeter. Altimeter tells the height of the aircraft from sea level. Next one is tail coordinator. Tail coordinator is nothing but tells the rate and direction of the airplane from vertical direction. And what are the other control surfaces used in aircraft? One is flaps. Flaps is used to change the camber of the wing. And next one is spoiler. Spoiler is a device which is used to adjust the downforce generated by the wing. Next one is slats. It is used to enable the airplane to get off or ground quickly or suddenly. Next one is airfoil section. This is airfoil. Airfoil is nothing but the cross section of the wing, and this is leading edge and this is trailing edge. This line is nothing but the chord line of the airfoil. Here the different types of knockout series airfoils are used, that is 4 series, 5 series, 6 series. And this is the angle of attack diagram. The angle between the chord line and the relative direction of the aircraft. This line shows the relative direction of the flight, and this is alpha. This is nothing but the angle of attack. Angle of attack is nothing but the angle between the chord line and relative direction of the flight. And next one is unsymmetrical airfoil graph. This is lift versus angle of attack drag, and this is the stall region. There are different types of theorems used in aircraft movement. One is Bernoulli's theorem and Newton's motion of law, and Bernoulli's equations. And this is the diagram shows the VN diagram, that is velocity versus load factor diagram. First of all, what is stall? In a particular condition, the aircraft cannot fly steady or safely. It is called a stall region. At that condition, lift and drag are cannot produce it. And next one is, if there is any problem arising from the flight or the other topics involving in the flow of air, the term aerodynamics is generally used. First of all, what is aerodynamics? Aerodynamics is a branch of dynamics concerned with the studying the motion of air, particularly when it interacts with the solid objects. Aerodynamics is the subfield of fluid dynamics and gas dynamics. Fluid dynamics is nothing but the deals with the fluid flow, and gas dynamics is nothing but the study of motion of gas. Understanding the motion of air around a solid object enables the calculation of force and moments acting on the airplane. And this is the diagram shows force and moments acting on the airfoil. Airfoil is nothing but the cross section of the wing, and this is the lift and this is the drag, and this is the dotted line shows the aerodynamic forces of the airplane. And this is the angle of attack. Angle of attack is nothing but the angle between the chord line and relative direction of the aircraft. And next one is properties. The difficult properties include velocity, pressure, density, temperature to find the spatial position and times of the aircraft. Usually the use of the aerodynamics through mathematical analysis, empirical approximation, internal experimentation and computer simulation through the heavy than aircraft and number of other technologies, etc. And next one is problems. Aerodynamics problems can be classified according to the flow of environment. One is external aerodynamics and next one is internal aerodynamics. What is external aerodynamics? External aerodynamics is used to study of airflow through the solid objects, and next one is internal aerodynamics. Internal aerodynamics study of airflow passing through the solid objects. First one is external aerodynamics. External aerodynamics. Example for the external aerodynamics. A lift and a drag, avoiding the lift and drag and the sharp edge that forms in front of the nose. These are the example for the external aerodynamics. And internal aerodynamics is used to study the airflow around that is passing through the solid objects. And another problems can be classified according to the flow field. That is whether the flow field is above or below or near to the speed of sound. It has to be subsonic, transonic, supersonic, hypersonic and sonic. The speed of the aircraft classified to the Mach number. Mach number is nothing but the velocity of the moving aircraft to the speed of sound. Here the Mach number for the subsonic aircraft is less than 1 and transonic between 0.8 to 1.2 and supersonic 1.2 to 5 and hypersonic is greater than 10. And next one is what are the basic aerodynamics principles which has to be used in to solve and analyze the problems in aerodynamics. One is continuity equation. Continuity is nothing but the rho 1 A1 V1 equal to rho 2 A2 V2. And next one is Bernoulli's equation. Bernoulli's equation is already told an ideal incompressible fluid, the sum of the pressure energy, kinematic energy and the potential energy constant along the stream when the flow is steady and continuous. And here P1 plus rho into A into V1 square by 2 equal to P2 plus rho into A V2 square by 2. This is the Bernoulli's equation. And next one is Kutta-Joukowski theorem and measurement of airfield, linear momentum principle. These are all the things which has to be used in the aerodynamics to solve and analyze the problems. If the problems arise from the flow of air and the other topics involving in the related to the aircraft movements, the term aerodynamics generally used. And this is the basic aerodynamics principle which has to be used to solve and analyze the problems when there is problem arising from the flights. And this is the diagram shows the shock waves that forms in front of the nose. It has to be three types. One is weaker shock wave and another one is stronger shock wave, another one is normal shock wave. And this is the diagram shows the shock waves that forms in front of the nose of the aircraft. And final one is application which in aerodynamics generally used in other fields. One is automobile to design the automobile components, and next one is sailing to prediction of force and momentum acting on the sailing, and next one is structural engineering. In structural engineering to find the wing loads when we are going to design the large buildings and bridges, etc. And these are all the things which has to be related to the aerodynamics and best of my knowledge. Thank you.